This is a very quick and simple little one on friction, but hopefully it helps to nail down how friction works as a concept. So Cassie wants to do a burnout. The proportion of the mass of her car on one tyre, because it's not the whole mass of the car, it's only how much is pressing down on that particular tyre, probably quarter of the mass depending on the way the car's balanced. So she is going to have to break that friction. So that will be the static friction because the tyres are not spinning relative to the road, but she wants them to be. So the static friction is 0.89. So the frictional force that's applied is just going to be F frictional, F frict, equals mu, the coefficient of friction, times the normal force. The normal force in this case, sorry, can't spell norm, the normal force is the force acting downward on the tyre. So I'll draw my diagram, but I'm just going to draw the tyre rather than a whole car. The force acting downward on the tyre is, well, we don't know yet. The mass acting downward is 683 kilograms. Yep. It's only getting worse. So, but that normal force is just going to be the weight force of the car. So the weight force of the car, or at least this proportion of the car, is just mg. The acceleration, the mass times the acceleration due to gravity, or the force due to gravity. Remember, I keep saying the mass in this case is 683 kilograms, and g is 9.8 newtons per kilogram, which is the other way of saying meters per second squared. So 9.8 newtons for every kilogram means that that is going to be the actual force in newtons. But let's do it in pronumerals instead. So mu times mg. The frictional coefficient, remember, which has no units, times the mass times g. So 0.89 times 683 times 9.8 equals 5957 Newton. So now that's a value, that's the threshold value. The force must actually be, so this is the value of the force of the friction. F car, the force provided by the car, must be greater than, not even just greater than, equal to, it must be greater than 5957 Newton in order to actually break traction and do a burnout. Making no judgments about the social desirability of doing burnouts, but Cassie wants to do one. And the car has to provide a force greater than almost 6,000 Newton to do that.